Section 5.2, Ways to prove that quadrilaterals are parallelograms. In Section 5.1, we were given information about parallelograms, and that led us to 3 theorems that we could use to talk about the sides and the angles in the parallelograms. Now what we're doing is we are given a quadrilateral, and we're given some information, and we need to see whether or not we can prove that those quadrilaterals are parallelograms. Just like the theorems that we had in 5.1, we now use those same 3 theorems as converses to prove that quadrilaterals can be parallelograms. The first theorem: if both pairs of opposite sides of the quadrilateral are congruent, then the quadrilateral is a parallelogram. If the diagonals of the quadrilateral bisect each other, then the quadrilateral is a parallelogram. The third one you should also know: if both pairs of opposite angles of the quadrilateral are congruent, then the quadrilateral is a parallelogram. The one that's different is almost a combination of 2 of them, but it's a little bit tricky, so you need to be careful of the wording. If one pair of opposite sides of a quadrilateral are both congruent and parallel at the same time, then the quadrilateral is a parallelogram. What I'd like you to do right now is to please try to see if you could prove that. Give yourself that one pair is both parallel and congruent in a quadrilateral and see if you could prove that it's a parallelogram. Remember, to prove that it's a parallelogram, you need to be able to come up with one of the other 3 reasons in order to prove that quadrilateral. Please take a look at these 2 examples and be ready to explain whether or not they are parallelograms. Here's the first one. Draw the picture somewhere on your notes and tell me yes or no and why. Here's the second one. Draw the picture on your note sheet or in your notes and tell me if it's a parallelogram, yes or no, and why.